Hello all, welcome to the EcoTeq Academy webinar, Busting Battery Myths. Today we have Zach Mersch with us, joining us from the States. Zach's been deeply involved with the research, production and improvement of commercial battery mowers for over 10 years, has a very deep understanding of commercial battery technology. Most of Zach's knowledge has been gained through real-life experience rather than through theoretical knowledge, which is why I'm so excited to have him on board here to share some of what he's learnt. We will be answering questions at the end of this webinar. Please feel free to post any questions in the chat. Thanks again for joining. Handing over now to Zach. Zach, did you want to introduce yourself to the audience?
Yeah, hey Braden. Yeah, thanks for having me on. I really appreciate it. Yeah, my name is Zach Mersch. I'm regional sales manager at Mean Green Mowers. I've been with Mean Green Mowers for over almost 11 years now. My uncle, Joe Conrad, my cousin Matt Conrad started Mean Green back in 2009. We've only built electric mowers. So just to get an idea of where we started from, the idea was to get through a 5-acre plot with an electric mower. And at the time, all we had was, lead acid batteries, deep cycle lead acid batteries. So our first 60-inch mower had a lithium pack on it that went about an hour and a half, and it weighed about 800 pounds. And now today we have our current rival 60-inch mower that has a 320-pound pack that'll run over 8 hours a day. So, really excited to have this discussion to, see, what people's concerns are, things like that, and try to help, eliminate any of those fears of switching from gas-powered equipment to battery.
That's good. Thanks for that, Zach. Well, we'll jump straight into it. So I've just listed off, run through this with Zach. So I've listed off 6 of the key lithium batteries, and we'll just have a quick run through on each of them. But obviously each of these 6 batteries has a different chemical composition. The batteries that you guys are using mostly at the at Mean Green is the NMC battery. Is that right, Zach?
Yeah, we are currently using NMC. When we first went to lithium, we used the LiFePO4, which is what we see as the LFP now.
Yeah, cool. So this chart shows a visual representation of the strengths and weaknesses of each of these battery types in these categories. There's a couple of points here which Zach will run through, but your specific energy, which is your point at the top, refers to the density of the battery, which generally translates to endurance. The specific power, which you'll see the top left, refers to the ability to deliver a high current or energy on demand. You've got your performance at the bottom, which refers to the ability to perform in extreme temperature environments. Obviously, you've got your lifespan. I've kind of gone around this anti-clockwise, but that's all right. Lifespan, which loosely refers to charge cycles, the ability, obviously the more charge cycles before the battery degrades, the higher the lifespan of the product. You've obviously got the safety in there as well, which refers to, obviously, and it's going to come up throughout the webinar, battery fires, things like that, thermal runaway, and obviously the cost of the battery, which also is quite a large factor in determining which battery we're using. So did you want to give us a bit of the comparison? You said you used LFP originally. What were the differences between these 2 batteries?
Well, at the time that we started LFP, or what it was called before, LiFePO4, lithium iron phosphate, it was the first thing available at the time, and that got us from, the lead acid batteries that ran about an hour and a half to a pack of batteries in the mower that would run about 4 to 4.5 hours. And that's when we learned to really get, efficient on the mower, whether depending on what battery size you have, it depends on the use that you're having it as well. So it got us to the point where we wanted to make our mower perform and use that available power at the time the most efficient way possible. But as battery technology has gotten better, I mean, we've seen it in our cell phones, the LMO gets used in our cell phones a lot because of the specific energy and the cost. Those were 2 big factors there. But as most people know, a cell phone battery, 1 to 2 years, you start losing the life of it, things like that. The LTO, the LTO is a really good energy as well. But as you can see, the performance and the safety are off the charts, but the cost, isn't there. It is very, very expensive, to get into that
It's your,
type of
your
chemistry there.
titanium, obviously.
Yeah.
Titanium is a
Yep.
very, I guess, rare
Very, very
compared to some of these
costly.
other.
Yeah.
Yep.
Yep, it gets really costly. So as you look at these charts, the NCM really hits all factors in a really specific way. And, that's what drew us there, along with, lightening up the mower, but also having the density that we needed with that. The LFP creates a little bit more density. The LFP, you can get more charge cycles out of it, and that's great for like home storage and things like that. But for a mower, we don't need the mower to run 20,000 hours. We need the mower to run 5,000 to 8,000 hours. And that's where the lightness and efficiency came with the NCM that just made the most sense for us at the time.
Yeah,
And
sure.
then what we also created was a battery that we can put any chemistry we want in. So we typically see a big change in lithium batteries or just batteries in general every 7 to 10 years. So I expect over the next 3 to 4 years, we'll see another breakthrough, in battery technology that eventually we can just put in the same box that we have and continue building, the mowers that we have as well.
Sure. The other thing I noticed in a bit of my research with the LFP battery compared to the NMC or even the NCA. So originally, if we bring it back to EVs, which a lot of people do understand, the original Tesla batteries were more around the NCA batteries, which obviously had very good energy, so pretty reasonable run time, so they could get their claims right up there. They also had quite good specific power, but the safety was a little bit on the downside. So they've actually shifted more to using a mix of LFP and NMC batteries rather than the NCA. So the LFP batteries, in their eyes, are a very safe battery. Would very rarely have any, any incidents with that battery. You've got very high specific power. So where we're finding the LFP are more in your short range, high acceleration vehicles, because you've got a lot higher current draw. With the NMC batteries, it's more on your longer range, standard type of vehicles, but obviously with that longer endurance. Is that a simple way to explain it, Zach?
Yeah, pretty much, the LFP it's denser and you can get more charge cycles out of it. So you can use the battery more. But the way the voltage runs on the LFP, you stay higher, and then at the very end, you just drop off it. So it stays at a higher voltage. With the NMC, you kind of stay and you go to like a mid range, and you stay there through the whole thing, and then it kind of just tapers off at the end as well.
Sure.
So like just an explanation, like the last 20 minutes of the runtime of the mower, you can start telling the blades getting a little bit weaker, things like that. We just don't completely shut it off because that's the way the battery is dissipating towards the end.
Yeah, sure. Okay, cool. We'll bounce on to the next slide, which is more comparing your specific energy, so your endurance, because it's obviously, as what we were saying before, what we view as one of the most important factors. So obviously the NCA battery has by far the most endurance. However, it is a higher cost and compromised safety, which can obviously rule it out of many of these applications. The LCO battery, which is the next one down, so that's your lithium cobalt oxide, is also very good endurance and it's affordable, but it's got quite low specific power. So which is why Zach was talking about it before, being used in things like mobile phones, hand tools, but it doesn't have a very high current draw, which rules it out of being a true contender for commercial applications. The NMC battery is the first battery there with good endurance. It's not cost prohibitive, has obviously a high safety threshold and a good lifespan. So essentially what we're saying is an all-rounder with great endurance. So did you want to delve a bit more into the pros and cons of LFP and NMC? Obviously you've gone through it a little bit already.
Yeah, so the LFP, has a lot more iron in it, and the phosphorus side of it we use in the nickel and the NCM. We use a lot more nickel, magnesium, and cobalt. And what I thought was interesting about this chart is that we really don't have the whole lot of where the lithium is in these batteries. And when we talk about lithium and things like that, how much lithium takes to make a lithium battery, it's a very small percentage. I've heard anything from 3%, to 5% of The battery is really just made out of the lithium to keep the stabilization of the energy and things like that. So I call it like a little pinch of salt, when it comes to the lithium side of it. But that's where you get your charge cycles and things like that by either the nickel or the iron, things like that. And then you got your, in the NCM, you got your magnesium and cobalt to help level that out as well.
Sure. And when we're talking about these chemistries, typically there's two parts to a battery. You've got the cathode and the anode. So from my understanding, you can correct me if I'm wrong, the anode is your negative, which is typically made out of graphite or sometimes silicon, but obviously silicon does have troubles conducting electricity, whereas graphite's quite conductive. But then it's the cathode that changes in the chemistry, and that's what gives the battery its power, its safety, or its endurance. So we're talking the cathode here with a small percentage of lithium, and it's that part of the battery that's changing from a lithium battery to another lithium battery. Is that right?
Yes, that's correct.
So essentially, the cathode is your positive, your anode is your negative, and when it charges, it draws the electrons from one to the other, and then it discharges, it draws it back out, back through the graphite. I don't know. I don't know. I've only had a few years in this, Zach, so you're probably laughing at me inside.
No, I'm not, because every day I'm still learning a lot about this too. I mean, while I've been in battery technology for a long time, I'm not an engineer in a battery and things like that. So I like to call it pixie dust sometimes. It just depends on how much pixie dust you want to use of certain types, but it does play a factor in, how fast do you want to charge? How fast do you want to discharge? What kind of heat are we looking at? All these kind of things, because, when you're charging or discharging a battery too fast, these metals in there start heating up, and that's what starts deteriorating the cells. If you're properly using the battery for the recommended charging and discharging of the battery without, creating heat or getting it too cool, that will expand the life of the battery. Our battery actually gets stronger the first 600 hours you use it before it starts kind of dissipating. It actually gets to about 110% capacity and then starts working down from there. But that's also in conjunction with like the battery management system that we have.
Okay, that's cool. The other thing I was working through, so your NMC battery, which was saying is it's better energy density, so better endurance, good for cold weather performance, but they're obviously more expensive. The LFP battery is cheaper, has a more stable cathode chemistry, but it's obviously heavier, has less endurance. What I've most commonly in the research that I've come across, we're looking at about 130 watt hours per kg for the LFP, while you're looking at more around 200 watt hours per kg for the NMC. That's sort of what I've just come up with, but I don't know whether that's correct or not.
Yeah, it's typically about 20%, 25% is what we've typically seen. So I think that number sounds about right, yes.
Probably a little low on the LFP side, then it's probably more like around 150 watt hours or something like that, but that's cool. Bouncing on.
Yeah, that sounds right.
Cool. Bouncing on then to some of these common battery myths, which we do hear of now. I'm asking you to give me a hand with some of these, but the probably the most common ones are these first four. So cell failure means battery failure, and that's expensive. Can you run us through how we overcome the need to replace a battery if we do have batteries failing?
Yeah, that's something we worked on really hard for a long time. We have one of the first, true repairable batteries out there on the market. And we don't just replace one little cell. We don't run the little cylinder cells that you see, the Panasonic cells that you see. We run pouch cells, and we put a pouch cell into what we call a cell module. So this module is consisted of about 13 different cell pouches. And then we have 13 modules that are in this battery pack to create our 48-volt system. And then we have a pretty much, I'll call it a computer, but it's called the BMS, the battery management system, monitors each one of these cell modules. So it monitors it as we charge it and discharge it. And our battery is only as good as our weakest module. So when it comes down to our weakest module, if one gets out of tolerance enough, it'll send us a code and let us know, hey, this module is not really keeping up with the pack. It's getting far enough out of balance that we can then send out a new cell module and have one of our certified dealers or EcoTeq here be able to repair that cell module and get the mower back up and running for minimal cost compared to having to replace an entire battery pack.
Sure. Okay, cool. Have you seen much in the way of cell failure, Zach?
For all the batteries that we have out there, we have seen a 0.03% replacement. So we are very happy with how the batteries have held up and performed. Yes.
Cool. And would that be due to the fact that most of them, obviously you spoke about charging fast and discharging, creating heat. Most of yours would be on a slower charge, sort of like an overnight cycle. Is that part of the reason that you feel you're not having battery failures potentially?
Yeah, well, if we talk about lithium batteries that we built when they first came out, 7, 8 years ago, compared to what we built over the past 3 years, just the technology that it takes and the computerization that it's had to make cells and make them so much better, has a big part to do with it. Everything is very precise. Like we used to have a tolerance of like zero point 0.2, zero point 0.2 volts or something like that, that we thought, oh, that's a good battery. Well, now if we see a battery that's like 0.006 difference in cells, we go, oh, we should be kind of looking at that. That doesn't quite look right. So, because of how we build it, it's gotten so much better is why, we just don't see that. And with the new BMSs in there that monitor it on the charge and discharge and keep them balanced is also a big factor in why we don't see that happening. Typically, if we see something, it's probably because it just wasn't manufactured right and wasn't quite built to the spec that we needed, and that typically happens under the warranty.
Okay, that's cool. The next point there, just bouncing on, batteries lose power as they get closer towards the end of charge. This is true in a way, but what's your take on this one?
Well, this is a very true statement. All batteries will lose power as we get towards the end of the charge. So the question is, what do you do with that? I know my DeWalt drill, my new lithium DeWalt drill. When I'm sitting there, I'm in drilling a hole out, and I'm in the middle of this big old board. It's just going to stop. It's not going to give me a warning. It's not going to slow down. It's just going to shut off. Well, we don't really want to do that with mowers or cars or anything like that out there on the market. So, what we do is we set our tolerances to the mower understands where the battery's at. So once the battery gets so low, the mower will shut off and you'll have 20 minutes of drive time to get back where you need to go. And even the battery itself will will shut itself off even 5% before the cells are really at their minimal voltage. So we don't ever let the cells get low enough to hurt the battery. But towards the end, and with lithium, you'll see it at the very end, just like even DeWalt, drills. You'll feel it lose power for just a little bit, and then wham, it'll just shut off. And that's pretty much the same thing with all lithium.
Whereas with the traditional lead acid batteries, you can definitely feel it slowing down all the way, right from the word go. You can feel it slowing down. So it's not quite that extreme.
Yeah, or like you're trying to start your car and it's like, wah. Well, you're like, come on, just turn it over one more time.
Yeah.
Lithium, it's not going to do that.
Yeah, it's either it's on or it's off. Cool. You need special charging infrastructure. While this might be true for some cars, obviously the bulk of the mowers that you guys are producing and a lot of the maintenance equipment that we've got, obviously standard 240 volt, 10 amp charging, the bulk of it, 15 amp here in Australia, sometimes for the larger batteries. The other point is batteries produce too much heat. Where's this likely to happen, Zach?
The batteries produce too much heat. Typically, batteries will produce too much heat if we discharge or charge too fast. Our mowers won't discharge the battery fast enough to create more than like a warmth temperature inside the battery, just kind of get it to like a lukewarm. And our batteries actually like performing from 80 to 100 degrees. That's when the lithium is the happiest at that point. So we do want to keep heat away. We use aluminum casing and metal casing around the batteries to dissipate any heat or not allow any heat to get to it. If you see batteries that have a black casing or black plastic casing around them, we've seen those batteries sit out in the sun and create just an external heat from the sun and warm up the batteries to where they won't perform. And we've never seen that with our mowers with the aluminum casing and things like that dissipate the heat from around it. So as far as internal heat goes, all of our batteries can actually charge or discharge in 1 hour. That's what they're rated to do. They could do that if we want, but our mowers will run for 8 hours, which means that we're taking that charge cycle and we're dissipating it over 8 hours instead of the 1 hour that it's actually rated to be able to do. So in that aspect, we're keeping the ratings very, very high to have a good charge cycle at that point. And then our charge times are 12 hours or less, and technically it could charge in 1 hour if we wanted to. But the longer we let it charge, the less that we're going to create any internal heat or things like that, compared to like a cell phone battery.
You get out of your battery.
Oh yeah, and like a cell phone battery, oh my gosh, when certain phones came out, they came out with this fast charging, and this little battery is going to charge, in 20 minutes or something on your phone, and it created a lot of internal heat, and that's kind of where you can, understand, a battery can only charge so fast without being, cooled at that point.
Sure, that's cool. There's just on this next one, we've got a little video which I'll just skip through to it now. Full day of workout of battery powered equipment. Can you hear that, Zach?
Yep. Most people see the benefits of switching to an electric mower, like this EcoTeq rival. The question many ask is, will it last a whole day on a single charge? Well, the answer is yes, it will. But don't take my word for it. See for yourself. Using time-lapse footage, I'll now demonstrate how this machine can go for an entire working day, non-stop. Actually, I've got a much better idea. Braden here will show you that this mower can keep going for an entire working day, non-stop. And I'll just time it. Not only will EcoTeq electric mowers cut for an entire day, they can also be fully charged overnight while you're sleeping. Great job, mate. So you see, a whole day's mowing on a single charge. Great job. Go to ecoteq.com.au for more info and to book a demonstration.
Which that's basically what you're talking about anyway, Zach.
Yeah.
Obviously, I just thought it'd be fun to include that.
Oh, that's good.
It made me laugh the first time I saw it, but anyway, hope everyone enjoyed it. But the other point is diesel equipment will last longer than an electric equivalent. Now, a lot of people understand there's a lot more moving parts in a diesel machine. However, we have seen diesel machines still operating 20 years down the track. I don't know whether it's because they don't get used much or whether it's because they get well looked after, but what are your thoughts around the lifespan of a diesel engine compared to a battery powered piece of equipment?
Yeah, so our batteries are rated for 1,500 charge cycles, which puts you at about 8,000 hours of use before you reach 90% capacity. I've really never seen, out in the wild, a gas or diesel mower with more than about 4,000 hours on it. And with 4,000 hours, you talk to the mechanics and they've replaced the deck, they replaced all the spindles. They put some work into keeping that mower going, but because the motor was good, they put the money into it to keep it going. So my whole theory is if the battery's good and, which is the main, producer of what you need for an electric mower, if the battery's good, then you're going to do the same thing with an electric mower. So I don't see why you wouldn't go just as long, if not longer, than any diesel or petrol mower out there on the market.
So just on that, you're saying 1,500 charge cycles is about 8,000 hours. So is every time I plug it in to charge it, is that a charge cycle? So are we talking 1,500 days if I'm using it every day, or what's the theory there?
Yeah, so there's a myth out there that if you use it for however long you use it and then charge it back up, that's a cycle. With the lithium, with the NCMs, if you use 50% of the mower's battery that day and charge it up, you use 50% of that life cycle. So then the next day, if you use another 50%, well, then in 2 days, you've used a life cycle, at that point. So to equivalent to hours, yeah, 8,000 hours is that 1,500. And you're only at 1,500 hours, you're only at 90% capacity, or the battery still has 90% capacity. So instead of getting your full 8 hours, you get more like, 7.5 hours or something like that out of it at that 1,500 hour mark. Now, a lithium battery, just so we can kind of compare what we're talking about, a lithium battery is considered used once it reaches 80% capacity. So you're not supposed to use a lithium battery past 80% capacity. So our what we talk about is just even reaching 90% capacity at that point.
So what you're saying is if you're talking to the 80% capacity, you could probably get more like 12,000 hours out of it.
More than likely, yeah.
Yeah, sure. Okay, that's cool. Then we've got, to be perfectly honest, this one's come through some of the other team members. I haven't heard a whole lot of people saying that the internal combustion engine equipment is more efficient. Potentially, they may be talking about the way it processes the grass or the way it sweeps. I don't know, but yeah, I don't know. What's your take on this one, Zach?
When it comes to more efficiency, we found that all gas products in general are very inefficient. They never took the time to figure out how to lighten the mower. They never figured out the time to figure out how to run their blades and their baffles properly to run it. So, when we came into this industry, we thought, my gosh, there's got to be a better way. So, we use a lot of aluminum and steel. We run our baffling and our blades a certain way. Even the tip speed of our blades, when we put our blades in the grass, being electric motors, we got instant torque to the blades. So typically when a gas engine hits or a diesel engine hits the grass and bogs down, it loses about 10 to 15% efficiency on the tip speed of their blades, when we only lose about 3% efficiency on the tip speed of our blades. So this is just a, completely false assumption, thinking that. But the way they've ran the gas ones, every time they add a bigger blade or more weight, they just add more horsepower or a bigger engine, which just consumes more fuel and more maintenance and everything else you got to deal with.
Sure. The next one is a quite a common one. Myths about battery chemistry and safety. So the fire risks of batteries. We've kind of covered off on this a little bit, but what's the main mitigation that you guys do to make sure these things don't burst into flames?
Sure. So, typically a battery doesn't burst into a flame. Typically there is a reason or a rhyme to why it happened. We have a battery management system that monitors the resistance in cells, that monitors the cell difference. Typically when a cell module gets out of balance, it's typically because a cell starts shorting out. And if you don't, if you don't take care of that issue, once it gets to a certain tolerance, if you push past what's recommended, you could have something. But there's been a lot of research done on this, and I'll say this much: even in the past 4 years, I got to watch our battery manufacturer take a cell module and purposely overcharge it and get a thermal runaway to happen. And it went up kind of not quite like what you see here, but it had some flames, lots of smoke, things like that. Well, now they make these module covers to where it completely surrounds the cell module, and with this it eliminates all like the heat and smoke. It really condenses it down, because I'm not going to sit here and say that we'll never have with batteries that we'll never have an issue, but with all of our safeties in place, we should know about it way before it happens. And so the safeties become really so much better over the past 5 years. It's just crazy. But we also haven't seen a whole lot. I mean, to be honest, I've been all over the world and I see more diesel or petrol mowers that are burned up to a crisp with the trailer and everything, because they're out that day and something happened, whether a hydrostatic hose came off and it burned up or something like that. So whether it's gas or electric, I've seen some fires before, but I've never never seen one while the operator was out there operating the mower at that point.
Yeah, sure. That's cool. And then the final point we've got is myths around environmental impact and sustainability. So we've got, obviously, we can now recycle these lithium batteries. There are places to recycle them in Australia even, but it is still fairly new. And there's obviously these concerns around mining, there's concerns around the actual disposal or recycling of these batteries. What can you tell us there, Zach?
Yeah, so I've seen some really neat companies start recycling everything from Tesla batteries to cell phone batteries, anything you can think of, and they're repurposing them into new batteries. So one of the things you think about when it comes to mining and everything else, when we mine lithium and when we mine all these precious metals that we need to create the lithium batteries, these batteries can be melted down and reused 10 to 15 times before the impurities, get to the point where they get, pulled out and have to, be disposed of. So, lithium is going to be around for a very long time, even through the first one. So we're talking about lithium possibly being in just one mower, one battery for over 15 years. And now we can do that, 15 times. We're talking about a lot of years that we'll be able to keep that battery and that lithium around, supplying energy to any of these electric products that are out there.
Yeah, that's good. It does answer a lot of questions. Most of that is known to myself, but I didn't realize that you could do it up to 15 times. I knew you could recycle them, but
I probably should have said
astounding.
10 to just be conservative, but I've heard anything from 10 to 15.
Yeah, sure. Okay, cool. That's fine. So we'll bounce on now to if there are any questions. We have had a few come through on the chat. So I'll just quickly bounce through. There's actually two things here. There's a Q&A and there's a chat. So I'll start off with Daryl said, why do you see so many lithium e-scooters and bikes going up in flames? It is quite a common one, Daryl. We do get asked this quite a bit. Now, what I will say is, especially on the cheaper line of equipment, so when you're talking your e-scooters and bikes, they don't have a very sophisticated BMS system to actually manage that battery. The other things that can happen quite regularly on scooters and bikes is people have a stack, they fall off the bike or something, they have a cracked battery casing, whatever it might be, or they're using the wrong charger. There are a lot of things with e-scooters and e-bikes that can actually create a thermal runaway, whether the battery is just too old. There's a lot of things surrounding it, but if you do have concerns around that, more than happy to take it offline and we can run you through some of these scenarios as to what you may have seen. Keith Loveridge also says, health risks of diesel emissions from the mowers to staff and public also need to be included. Appreciate your comment, Keith. It's good. Alan McConnell says, will you have a recording available? Sorry, go on. Go, Zach.
Yeah, we actually on the health study, we have people here in the States, quiet communities, things like that, done a lot of health analysis and things like that from workers that have gone from petrol and diesels and things like that to overall, when they get done on the job site, they're much happier and they just didn't have to inhale all that stuff. And then in Europe, they have a hand-arm vibration test. So on electric mowers, over in Europe, they can only use mowers like 3.5 hours a day because of the vibrations that it puts on the operator. And with ours, they can mow like 13 hours a day because of the little vibration that it puts to the operator as well. So yeah, we've been doing quite a bit of studies with human health along with arthritis type testing and things like that. It's just crazy when you really get down into the weeds what you can find on some of that kind of stuff.
Sure, that's good. Alan asked if we'll have a recording available. Alan, yes, we will. We'll send that through for you. Then Marek has said, you mentioned battery recycling. Where can that be done in Australia? I'm not assuming you'd know the answer to this one, but there is a company in Melbourne called EnviroStream. They are fairly small at the moment. They have started recycling some of the larger lithium batteries. They've mostly been doing things like vapes and phones and all your smaller or hand tools, things like that. But at the moment, there hasn't been a large enough market for the large lithium batteries. because obviously they're still fairly new. They haven't got to that point where they're needing recycling. There has been a few, and they will obviously scale over the next 10 years. But yes, there is people that will do it. There's a couple other questions come through on these charts. Just jump back to the top here. Ian Garrold, our car has an LFP battery, more than happy with it for this purpose. That's great, Ian. They are a good battery, very stable. And for your shorter distance, they're a brilliant battery. You get a long life cycle out of it. Keith, Loveridge, air and noise pollution. That's good, particularly around parks, gardens, children's playgrounds, sweeping. Ian, again, what is the battery capacity of the mowers in kilowatt hours? Can you answer that one?
Yeah, so we have battery ranges from our smallest one, which is an 11.5 kilowatt. Our 60-inch mower has a 14.5 or a 22 kilowatt. 74-inch has a 22 kilowatt or a 35 kilowatt, and our new 96-inch mower has the 44 kilowatt battery pack.
He's asking how the performance is in long wet grass. So rather than a reflection on the battery, this is more a reflection on obviously the draw of the motors. So that this is kind of another discussion for you anyway, Ian, but we will reach out to you after. So yes, we will say that it's as good as a diesel mower in long, wet, thick grass, providing you've got the deck set up right, you've got your blades sharp, whether you've got your mulching baffles in or out. There's a lot of things to get a mower set up to the application that you're trying to use it for. So yes, it will do as well as a diesel machine if you've got it set up for the application you're trying to cut in. Then we've got also Ian, you've put a lot of stuff in here. Cobalt comes up in conversations around batteries being troublesome, but much of the world's cobalt is used in the refining of petrol and diesel. That's something I didn't know. Did you know that, Zach?
I knew about diesel. I didn't know petrol at the same time. So I learned something new there myself.
That's good, Ian. Appreciate that. We learn a lot of stuff when we go through these things, so it's good. We've got Sanya Afro's, the above article by University of New South Wales says 450 fires across Australia. So that is true. There is a lot of these fires in your smaller equipment like your bikes and e-scooters and things like that. And it does come back to that battery management system. You'll generally find they're a cheaper lithium scooter. People think they can jump on the bandwagon and just produce battery equipment without doing the research into it. So yes, there is a lot of them, which is why it is a very widespread myth. Don't know if you had anything to add there, Zach.
Yeah, I would like to say this too. You know, a lot of people don't understand battery management care. You know, if they let a battery sit depleted for a long period of time, you know, say the battery, you know, without charging it back up, things like that. And same thing, like I see all these e-scooters and things like that out in the cities just laying there for weeks at a time because no one goes around, collects them and charges them. So then it's been sitting for who knows how long, 2 months, 3 months. You know, you never know. They go to charge it up, and the next time they're using it, you know, it's a cell is shorted in there, and something, you know, happens. So battery care is a fact, you know, is something that we need to take into consideration when we're buying, especially, you know, these bigger type batteries for bigger equipment. We want to take the time to take care of them, just like we change the oil in our gas engines and, you know, grease all the spindles and everything else. You know, there is still a little bit of care there that you want to take.
That's good. There's a couple more come through while I've been talking. One from Gavin. A lot of EVs have longer warranties for the motor and battery than the car's warranty. Is this the same for the Mean Green and EcoTeq mowers? What are they versus internal combustion versions? So I guess what he's asking is the warranty on the battery longer than the actual machine itself?
We used to have a battery warranty that was longer than the machine, but we want to stand behind our products. So both the battery and the machine have a 5-year, 1,500-hour warranty, which pretty much goes past most of your diesel and petrol, you know, warranties at that point.
Yeah. So what you'll find with the more common mowers in Australia is they're either a 2 or a 3 year, and typically 750 hours on the warranty side of things. But and then also Gavin says, do you recommend we use timers to charge the batteries mowers to reduce risk of overcharging, degradation, and thermal runaway? So the smart chargers will overcome that, but did you want to give a run through on how the smart chargers work?
Yeah, so our chargers will charge the battery all the way up and shut off. But really what's monitoring it is our battery management system inside the battery. If that charger was to not shut off at the proper time, or if a cell was getting a little bit higher than it should, it'll shut the charger off itself by not accepting the battery charge. So most of our safeties are in the battery management system, even though our charger is designed also to shut off at certain points. But it's just simply going to send power or not. It's not going to restart. You can keep it, hooked up for a whole week. It's not going to recharge it or anything like that. Once it turns off, it turns off. And you unplug it and you're ready to go.
Okay, so I've noticed on the mowers, as it gets right towards the end of charge, so it's at 98, 99%, it'll actually slow down the amps that it's drawing into the machine. So is that the charger slowing it down, or is that the BMS slowing down what it's actually accepting into the battery?
No, that's the way the charger's programmed. Yep. So once it hits a certain voltage or a certain percentage, it starts bringing the amperage down, so it tops it off properly. We don't need to top it off at the highest rate of charge. It's meant to stage down. Yep. Also, you'll notice if it's down at 0%, it also stages itself up. So it doesn't immediately start fast charging it right away. It brings up that voltage, and then at its biggest mid-range is when it's throwing in the most power.
So is that why they always talk about when they're talking about car chargers, they talk about the time to charge from 20 to 80%, because that's where it's at its peak charging.
Yeah,
I guess performance.
No, that's exactly it. That's where the main part of your battery, where the main part of the battery capacity is from. And that's why Tesla goes, if you're not going to use 100% of the battery, keep it in that mid range, because then you're not maxing the cells out at the high side and you're not maxing them out at the low side. And it keeps a very healthy battery.
Cool. One other question. Sorry, we'll have to wrap this up soon, Zach, so you can get to bed. I know it's getting pretty late over there, but one other question from Alan. Do you have a safe method of shipping batteries other than by sea, something that air carriers will carry? I'm not sure I understand that question. Do you understand? Otherwise, we might have to come back to Alan.
I think I understood enough of that. Yeah, because we really can't ship these size batteries by air right now. It all has to be in a container on shipping. And that's just because the shipping companies aren't, educated enough to understand, what kind of parameters, and they don't have the ability to vet each person that makes batteries all the time. This has become more stringent in certain areas. I see that getting better over the next couple of years as there's more education brought to the batteries and shipping and safeties and things like that. But right now, that's pretty much the only way. Now, I do believe one of our cell packs, like if we just need to replace a cell, I do believe we can ship that a little bit different. But I don't, at this point, it's still all ground shipping.
That's good. Thanks for that. I think that pretty much wraps us up. Zach, I really, really appreciate your time. Hope everyone that's still on here has found it informative and helpful as I have. I've learned a lot on here, so really appreciate it. And if you do have any questions, feel free to reach out to either Zach or myself. And keep an eye out for the next webinar, which will be in a couple of months on whole of life sustainability. So really appreciate everyone here. Thanks again, and have a great day.
Great. Thanks, Braden.